All right, so it looks like I got it set up. It looks like YouTube Live isn't as easy as I thought it would be, but finally got it set up. I, in the future, plan on doing a little bit more of these, get a little bit more practice with them as well, kind of how to use them. For this one, if there is any questions that pop up in the feed, I don't think many folks are watching this, but I'm going to skip that, maybe try to touch it at the end just to see how it works. So if anybody is online, feel free to just send some messages or whatnot through the chat. That way I can see how to interact with those. So to start it off, we'll be covering what is machine learning and its possibilities for AEC. This is part of the KC, Revit, and Python Meetup group. I started that a while back ago just for fun to try to meet local people because I had just moved to KC. So I wanted to meet local people that had kind of the same interests as me. It's been slowly growing. I try to host them every month or so. Sometimes it's harder. This topic is newer to me. It's been somewhat of my passion for about a year or so, and I feel like machine learning applied to the AEC industry is going to grow pretty dramatically, and then hopefully more people kind of start showing up to these types of live sessions and meetup groups, and we start seeing more of this being applied to the AEC industry. So I'm going to go ahead and just kind of start this PowerPoint and we'll work through it. So what is machine learning and its possibilities for the AEC industry? The agenda is kind of what is machine learning, supervised and unsupervised learning. This is going to be a really basic look at ML. We're not going to dive too deep into the algorithms themselves, such as classification algorithms, regression, and clustering algorithms. Then we'll talk a little bit about the possibilities. And then I'll briefly, I don't really have a slide for this, but I'll talk about things that you can do to get started and then kind of what you should learn. It's from my perspective and what I've learned so far, but there's plenty of resources out there that'll kind of guide you in the right direction. And at the end, I'll share some resources that can kind of help you figure out what it is that you want to go down, because the field of AEC and the field of ML is really wide. There's a lot of stuff going on in it, so there's a lot to learn, and so that means there's many paths that you can go down. And we will talk real brief, I think, at the beginning here about AI, because I'm sure a lot of folks have heard about AI and maybe less folks have heard about machine learning. So we will talk briefly about that. So we'll start off with what's machine learning, and as if you've seen some ML tutorials or people talking about ML, it's kind of like there's a ton of math involved, and a lot of the resources I share, they do have math, but that's not a huge. ML is built on math. It's built on statistics, which has a lot of math in it, but there's a lot of resources that you can use. And what you can do is, through learning ML, you can learn math. So if you focus on ML, you can kind of inherit the skills of math. It'll take a while before you start understanding it. I'm still learning it. And at the end, I'll share plenty of resources that you can take a look at that kind of take math from the perspective of machine learning. And then so this picture here is from an actual paper that was written. I can't remember who the author was. The link is below, but he shares this because essentially you'll see one, tutorial or paper that's all about math, and then another one, or not so much math, but incredibly complex. And then another one that just talks about all the great things that AI can do, or machine learning can do. And it kind of leaves you with a lot of questions. I'm hoping out of this presentation or discussion is to kind of point you in the right direction and point you to where you can start learning these things and getting a little bit deeper into how you can apply these in a practical way in the AEC industry. One thing is it's very limited, the AEC industry, in where ML is actually being applied. So there isn't very many resources, but I also think that's really great because it opens up a lot of opportunity to take something from another field and apply it in AEC. It allows you to be the first one to do it, and I think that's just really cool. So here's a brief video from Oxford that goes over ML, I think in a really visual and easy way. So I'm just going to briefly play it. It's about 2 minutes.
Our ability to learn and get better at tasks through experience is part of being human. When we're born, we know almost nothing and can do almost nothing for ourselves. But soon, we're learning and becoming more capable every day. But did you know that computers can do the same? Machine learning brings together statistics and computer science to enable computers to learn how to do a given task without being programmed to do so. Just as your brain uses experience to improve at a task, so can computers. Say you need a computer that can tell the difference between a picture of a dog and a picture of a cat. You could begin by feeding it images and telling it, this one's a dog, that one's a cat. A computer programmed to learn will seek statistical patterns within the data that will enable it to recognize a cat or a dog in the future. It might figure out on its own that cats have shorter noses and that dogs come in a larger variety of sizes, and then represent that information numerically, organizing it in space. But, crucially, it's the computer, not the programmer, that identifies those patterns and establishes the algorithm by which future data will be sorted. One example of a simple yet highly effective algorithm is to find the optimal line separating cats from dogs. When the computer sees a new picture, it checks which side of the line it falls on and then says either cat or dog. But of course there can be mistakes. The more data the computer receives, the more finely tuned its algorithm becomes, and the more accurate it can be in its predictions. Machine learning is already widely applied. It's the technology behind facial recognition, text and speech recognition, spam filters on your inbox, online shopping or viewing recommendations, credit card fraud detection, and so much more. At the University of Oxford, machine learning researchers are combining statistics and computer science to build algorithms that can solve more complex problems more efficiently, using less computing power. From medical diagnoses to social media, the potential of machine learning to transform our world is truly mind-blowing. To find out more about machine learning, visit oxfordsparks.ox.ac.uk, follow us on Twitter, and find us on Facebook.
So I think that's a really good introduction to ML. It's if you want to check that out, it'll be in this PowerPoint. I'll share it with you. You can also search for it. It's on YouTube. And so this is a nice little definition from the 100-page machine learning book. And as you see here, it talks about ML as solving practical problems by taking data sets and then algorithmically building a statistical model based on that data set. And then that statistical model is assumed to be used somehow to solve some type of problem. So ML it's almost like applied statistics, because a lot of what ML is doing is pulling from statistics and what statisticians have been working on, the different things that they use through their job. And what they do, what ML does is it pretty much combines that with computing. So it takes statistics, combines it with computing, and then you can start to use it to predict the future from the data. So here's the AI map or ML map. And again, this is from another blog or another paper or blog. And you'll check it out here. Here's a link if you want to read a little bit more about this. It's a really great paper. I definitely recommend it. It's really brief, and it kind of tells you what ML is and how it's applied in the real world. So in here, ML kind of is inside of AI. So artificial intelligence is like a wide umbrella. It's generally used when speaking with kind of the general population. Robotics is in AI, data science is kind of in AI. There's a lot of things under the AI umbrella. And machine learning is kind of a subset of that. And then you can dive even deeper into neural nets and then deep learning. Deep learning is kind of like it's built upon a lot of the basics that we'll kind of touch on. And it's very, very complex, but you'll see a lot of cool stuff coming out using deep learning. A lot of the stuff that DeepMinds is doing is leveraging deep learning. And DeepMinds is definitely something I would recommend. At the end of this, I do have a reference to their blog. But deep learning is a very complex topic, so I would recommend kind of avoiding that at least until you have the basics in place and you start to understand how to actually apply some of the basic ML algorithms. Here's a nice little chart. This again is from that same blog. And it's the classical machine learning, so that's supervised, unsupervised. There's some other ones as well, like reinforcement learning and semi-learning. We're going to skip those and kind of focus on these ones. So supervised and unsupervised. Supervised is pretty much that you have labeled data. The computer knows what the variables of a certain piece of data, like what it is. So if it was a cat or a dog, it knows the input. So it knows if it is a cat or a dog. And then what it does is it takes it and learns from it, and then it will divide it up and make predictions on that. So either not a cat, not a dog, a dog or a cat. Regression is kind of like for numerical values, so like height to weight. Unsupervised learning it's kind of like unlabeled data. So you take this unlabeled data, you throw it into a bin, and the computer itself doesn't really know much about the data other than the parameters that make it up, and then it essentially starts dividing it up based off of its parameters and progressively works through that until it has clusters. And as you see down here, clustering, which we'll kind of take a look at later, is something that's applied to the data to try to categorize it into separate bins. It's to almost give structure to the data. So we'll start off with supervised learning. The bulk of practical ML uses supervised learning. The data is labeled, and the ones that we're going to take a look at is classification and regression. And then we're actually not going to look at multi-class logistic regression. We're going to look at just logistic regression and then linear regression. So that's my bad, a mistake there. So supervised learning, again, it's labeled data. So you can see here, it understands that this input is cats. It takes it processes that, and then it takes now the unlabeled input, processes that, and tries to categorize it into one or the other. So these are cats, these are not cats. It understands that because you have data that was labeled as an input for it to kind of learn from. So with supervised learning, there's classification and then there's regression. So in this example, it's dog or cat. So classification is just sorting the items into categories. And then height to weight, the regression is, identifying real values. Generally, to leverage this, there needs to be a strong correlation between the two variables. So height to weight generally has a strong correlation. You know, the taller you get, the more you weigh generally. Logistic regression is one of the algorithms that you can leverage. And so it takes a number of inputs, kind of does its magic, the algorithm, and then it'll output if it's one or the other. And we kind of looked at that before. So, you know, in this example, is it a dog? Is it not a dog? Linear regression is it tries to fit a line across a bunch of data points that best fit the line to reduce the error between the point and the line. And as you can see here in this example, that's kind of what it's doing. So it's plotting that line, and then from there you can start to predict different things, you know, height to weight. You can start to predict based on the height what they'll most likely weigh. It's a very simple algorithm, and for starting with ML or machine learning, linear regression is the kind of like the first one that most data scientists or most ML people learn. It's the foundation for everything else. So unsupervised learning. So unsupervised learning is just that all the data is kind of unlabeled or it's unstructured. You know, the goal is to learn more about the structure of that data. The type that we're going to look are the types are clustering. The algorithm that we're going to look at is k-means. So unsupervised learning, we have a whole bunch of random data points. So we input that raw data. And we don't really know the inputs themselves. Like, we don't know what they're labeled. It progresses through that, and it tries to find, or moves to the center, kind of progressively takes those data points. Let's say they're all in one big bin. It will, all it understands of that data is the inputs or the parameters or features of that data, and it kind of starts to understand it through that, and then essentially moves them into different bins. But other than that, it still doesn't know what that data is. If it is a picture of a cat or something, it doesn't really understand it. It just knows that there's a number of features that relate to one another. So I'm just going to put this, these data points in this bin, and I'm going to put these data points in this bin because their parameters are all kind of the same. Are their inputs or values? And this is kind of a nice visual to kind of give you an idea. So it takes a whole bunch of inputs like you see in this A box. And you can see right now it's already separated. It takes these points and starts to understand and move closer and divide this up into a better or into clusters of data points. And you can see it progressively moves through this until you get to F, and now you have 3 clusters of data points, and then from there you're now giving structure to that data. You better understand it. And you can even take it further and subdivide these up as well. Over here we have burgers, pizza, and beer. Again, the idea is you dump all these data points into a bin, and then the ML just kind of looks at it and tries to understand the things that are kind of the same for the data points, and then divides them up into the different bins. So that's it really with the algorithms, those 3 basic ones. So k-means cluster, linear regression, logistic regression. So take a look at those and try to dive a little bit deeper into them. I recommend linear regression. It's a really easy one to kind of take a look at. So now we'll just take a look at possibilities. There's a ton of possibilities with ML, and this is a really great paper I recommend just reading. It's really brief, and in this one, in the paper, they actually test a variety of different algorithms, because that's part of the process, is trying to find what best, takes that data and actually gives you good output. So you're trying to find the algorithm that has the highest accuracy. So in this example, what they do is they input models, so different perspectives of that model, and I think they had a variety of models that they were using, but they were limited with data, so they took the same model and kind of took different perspectives of it. And for ML, that's kind of a new image that it has to learn. And then just progressively tries to understand it, and then it'll categorize it into apartments, industrial, building, or other. In this example, they only used 3. They did not have a lot of data, and the amount of data and the type of algorithms you're using does impact what you can actually do and what insights you can learn from it. The more variables up to a point, or more features up to a point, the more data that you have will give you better insight into the data itself, and allow you to do things like this or expand on this to group it into more than just 3 categories. But it's a really interesting paper, and I definitely recommend it. It's kind of like the first step into moving in the direction of automatically creating a model. This is a really nice article. It's about structural connections. So what it did was it learned from the previous models. So it was 2 for the training data. It learned from those, and then it looked at the model itself, and then it made the connections. The article is really interesting, and one of the things they point out is all the time it takes to do this manually. And if you can even, automate 22%, or in this example, 77%, then what you can do is take the time that you save. I mean, you could just take a portion of that time and maybe just back check that work to make sure that it's automating everything correctly. But you're saving, an exponential amount of time. But what it did was they applied ML to this to learn from it and then create the connections for them in the model. Here's another example from SmartVid.io. And what it does is you use image recognition. It understands the what it's looking at, and then it'll tell you if there's any safety violations. And it's a way to proactively monitor the site. And safety is a big expense on construction. And so using this system to monitor the site all the time is really great, because it's going to save money, but it also has the potential of saving lives, which I think is really important. And it isn't, all it's doing is it's just reading the environment. Trying to understand it, and then it reports back. It says, hey, this guy's missing his PPE, or this is a safety violation of some sort, needs to be fixed. But it's reporting to you, it's giving you that information, and then ultimately saves lives and then saves money. This is a really cool, there was an article written about it, definitely worth checking out. This is about, it uses GANs, and that's kind of a lot further than like linear regression, but I think it's really important to kind of show, the future and how we can start applying this in the AEC industry. You can see here when the walls flex, the geometry in the inside of the building flexes as well. So the walls move, the rooms move, all the interiors move, so all the furniture and stuff, and you can flex it, however way that you want, and then it's constantly kind of generating an output for you. And what it does is it actually learns from images from before, which is really cool. So a lot of companies have a ton of data which is really nice. Unstructured or not, there's ways to pull that data into something like this and then actually learn from it. And that's kind of what they did here with images. Here's another one from TestFit.io. I don't know how much ML is being used here, but it's really cool and it shows you the possibilities. So I mean, when they flex this, it will generate the different options for you. So it kind of iterates through them. And also the idea is, kind of on that topic of if it isn't ML, the idea behind ML too is so that you don't have to program every single variable. It's so that it actually learns and understands what it's doing, and it starts to create, these things or automate these things that a human would do. Some other ideas to think about. So, create all the CDs for a project, and that would be construction documents. Generate a model from images. Can we take the model size and then find correlations in billable time? Can we take the Revit project and try to understand profitability? There's just so many things that we can do, and there's so much data in the AEC industry that we can use. It's almost like it's never ending. There's just so many cool things. So from here to the end, we'll just take a look at some resources. I want to share these out. When I share this, I'll share the PowerPoint below the video. I'll post that, and then you can take it from there and kind of check these resources out and dive a little bit deeper. So the first bit is just some papers, and these papers are oriented towards BIM and architecture. They're really interesting. For both of them, I think they're taking their inputs are images and they're outputting them into some type of category. The other resources are courses, and I definitely recommend ML from Stanford, taught by Andrew Ng. This is on Coursera, and it's free. It's a really great course, and it'll give you a great foundation to kind of grow from into ML, and if you want to take it into deep learning, there's a portion in there as well, kind of talking about that. Python for Data Science, Essential Part 1 by Lillian Pearson. That's a really great course. It is about 6 hours long, at least the first one is. I definitely recommend it. It's Python oriented. It's for Python, but you'll learn a ton of stuff if you happen to be interested in R or some of the other languages. I think you'll still learn quite a bit from it. It covers a lot of the Python libraries as well, if Python is your language of interest. Python for Data Science Essentials Part 2. I haven't done that one, but going based off of the first one, I definitely recommend this one, or the Part 2. It's a little bit shorter. And Essential Math for Machine Learning. It's very basic, and I feel like if you don't have any math skills, which I kind of didn't have, it's a great course, and it's also Python oriented. They may have other languages out there, I'm not sure, but I definitely recommend that one if you're kind of newer to math or not that experienced with math. It's all oriented towards machine learning, which is really nice. Some books, so I do recommend these. I mentioned the 100-page ML book. The Master Algorithm, it's more theoretical, it's not so technical. Recommend that one. And then definitely the Hands-on ML with Scikit-learn. Again, these are all Python, or at least the top one's a Python book. Resources, podcast, Twiml. It's a really great ML podcast I recommend. ML, the Machine Learning Guide. I totally recommend that. If you get an opportunity to listen to it, try to do it while you're doing the Coursera course with Andrew Ng, because it's kind of a audio version of that, and you'll learn a ton. When you're doing Coursera, you do that, and then you kind of listen through the Machine Learning Guide podcast on maybe your car ride or at the gym, you'll get a lot of information. And then talk Python to me. If your focus language is Python, I definitely recommend Talk Python to me. It's a really great podcast, and there's a lot of information every week that comes from it. I listen to it quite a bit. You'll learn about new packages and new things that you may not have known existed in Python. Some resources, some blogs and articles. So DeepMind, which I mentioned before, and then some blogs here that are oriented towards the AEC industry. And then 5 AI programming languages for beginners in 2019. Check that out. Oh, and then the Ultimate Guide to AI, Data Science, and ML. It's a really great post, and it has a ton of stuff in it, like cheat sheets and a ton of resources, all oriented towards data science and ML and AI. Some other resources, and again, this list doesn't show everything. I'm hoping to kind of show you the resources, show you what ML can do and what its possibilities are, and then from here you can kind of dive a little bit deeper into it. So these are some other ones worth checking out, but this isn't it. There's so many more that are out there, and that's it. So hopefully you got something out of this, and if you didn't, definitely check out some of those resources, because Andrew Ng, for example, is an expert in machine learning, and you'll learn a lot if you check out his course. Let me know if you have any questions, and I appreciate everybody's time. Thanks a lot for kind of waiting on the live session. It had some technical issues, so hopefully the next one will go a little bit better. But thanks, everybody.
Bye. Let's go. I'm gonna get some gifts.